In this unit, we're going to be looking at numerical methods, and numerical methods are essentially approximation methods that we're going to use in calculus. And one of the main strategies that we use for approximation is something called linear approximation. So linear approximation is based on the fact that if we want to approximate values on the curve, if we look at any point on a curve and zoom in close enough, any curve point starts looking straight as we zoom in. So because of that fact, what we can do is we can take a tangent line at that point, and we can use that tangent line and say that that tangent line approximates points on the curve. And as long as we're close enough to the point of tangency, the approximation will be good enough for whatever purposes we need it for. And furthermore, the closer we get to the point of tangency, so as we bring that point closer, so points closer to the tangent point, the approximation gets better and better and better. So what we're going to do is we're going to take that tangent line and we're going to find that point by finding the coordinate on the tangent line, and then we can compare it to the actual point on the curve. So the tangent line is going to be based on having a linear equation. So that linear equation needs a slope. That slope is going to come from the derivative. So in blue here we have the derivative. And we also need a point. So I've highlighted in yellow here the point. And the equation of tangent line I've written in point slope form, where we have the slope. I'm just going to highlight there. We have our slope and we have our x and y coordinate, which allows us to come up with that tangent line equation. So in this particular example, we have a tangent at 0 on this polynomial. To come up with the tangent line equation, we're first of all going to calculate the derivative. So taking the derivative of x cubed minus 9x squared plus 18x, we end up with 3x squared minus 18x plus 18. Plugging 0 into that equation gives us a slope of 18. And then the coordinate we're going to use is 0, 0. So when we approximate that, well, we're just going to write down the equation first. The equation of that tangent line is going to be y is equal to 18 and then x minus 0 plus 0, which is our point of tangency. And using that coordinate, we plug in the value of, well, we want to approximate what's happening at point 2. And we plug in the x value of point 2, and we get the value on the red tangent line. We're going to end up with a value of approximately 3.6. Okay, so that value of 3.6 approximates the value on the actual polynomial, and the actual value on the polynomial is 3.25. And we can see that 3.6 is above the line, and we can see that the difference is approximately 0.35 is our approximate difference between the actual value and the linear approximation that we have in red.